This problem builds on the prior two questions where we were calculating out a stress and a strain in the cables that are holding an object. We're now going to calculate the change in length of the cables in units of microns or micrometers or micrometers. So let's go ahead and look at the relationship between what we calculated previously. Okay, so if we go back here, we calculated epsilon and what we are going to now calculate, which is the displacement or change in the length. So epsilon is equal to the change in the length delta divided by L, or the change in the length can be given by L times epsilon. So from the prior question, we had already come up with an expression for epsilon. So what we need now is just multiply by the length. And so we can do that, and we get this large expression. And here it is, all written out, hopefully with the right numbers. So we have initial length of 1.5 meters, which is given over here. We have a density here. We have a height of the object. We have a width of the object. We have a thickness of the object. These numbers seem correct. We have gravity. We have the 1/2, which we move down here. So it's divided by 2. We have our elastic modulus, which was given by 207 gigapascals, and the cross-sectional area of the cable is 0.2 centimeters squared. So let's go ahead and plug this into Google. And Google is still up from the prior example. I think, yep, over here, and we need to see if we have any different values. We do. We have a height of 0.9 meters, 1 meter, 1 centimeter, 9.8, 1,000, 0.5 in the front. 0.2 is still our cross-sectional area. Our elastic modulus is the same. We don't need to do times 1e to the 6th, because that would, or at least right now, we're gonna first multiply by the 1.5 meters. Okay, so we'll do 1.5 meters. And we just wanna see that this whole thing comes out to be dimension with lengths of meter. And yes, maybe we will multiply by 1e to 6 in a second because it wants the final result in micrometers. Okay, so let's see what we get. We hit enter, and oh, it was interestingly smart. Um, it didn't even ask us if we wanted in meters. It went ahead and it calculated it out in microns. So it's about 16 microns. I mean, if I want it to be in meters instead, I guess I can do this, and it will give us that result there. But Google was one step ahead of us. A little interesting and scary. Well, maybe not scary, just a little interesting. Okay, so now let's take a look at how we would do this in Colab. And we already have the script from our prior experience where we kept where we calculated epsilon. So I'm going to come in here, session 5, and we'll call this. Well, actually, we'll go ahead and do a duplication. We'll go ahead and do a save a copy, and we'll come up with a new script. It may our new notebook. Okay, we'll call this session 5, question 6. If you saw the previous video, I made some typos there. Worked it out though in the end because I was running both of the numerical responses in both Python and Colab. So here we've calculated epsilon. We do have a different value for the height, so we'll change that to 0.9, like that. And I think that's most everything, except we never put in the initial length. So we'll go ahead and put the initial length of 1.5 meters, like that. And we will then do a calculation for delta, okay? And yeah, it's just going to be L times epsilon. It's a little interesting, that already knows. And wow, it's already making another suggestion down here for what delta should be. So sure, I'll go ahead and take it, but I'm going to check it and edit it because I'm not sure if I like what I'm seeing there. Okay, because it was spitting out things in microstrain, and then when it did this, it said, oh, I think I'm going to multiply by 1e to the 6, which is good, but that's not going to give, we don't, the answer is not in microstrain, but it's going to be in microns. Okay, so when we run this, what do we get? Voila, we get 16.0 microns, which is what we got when we did it in Google. And you're like, well, what's about the rounding? It's a little bit different. Well, if I do to 3 decimal places, 15.978, 15.978. So we are getting identical responses. Thank you. I hope this information is useful.